Okay, so from today on, we're going to learn Unit 4, Characteristics of Functions. Today, we're going to have a look at Lesson 1, Sums and Differences of Functions. So today's learning goes, after this lesson, you should be able to understand that some combined functions are formed by adding or subtracting two or more functions. Understand that the superposition principle states that the sum of two functions can be found by adding the y-coordinates at each point along the x-axis, and that the superposition principle also applies to the difference of two functions. Also understand that the domain of the sum or difference of functions is the sum common to the component functions. Okay, so we'll use some example practices to illustrate these key concepts, okay? First of all, let's have a look at this example. Determine an equation for the function hx, which is the sum of fx and gx in each case. Then graph hx and state the domain and range of the function. So first of all, fx equals x squared and gx equals 3. And then we find hx equals fx plus gx. Second question, when fx equals x squared and gx equals x, we find hx and sketch the graph of hx. Okay, so first of all, I'll give you 10 minutes to think about this question by yourself. And after that, we'll have a look at the solution together, okay? Okay, let's have a look at the solutions for question A. Actually, hx is the sum of fx and gx, right? Which is x squared plus 3. Then we have two methods to sketch the graph of the new function. First, to produce the graph of hx, we can use a superposition principle. First, graph fx and gx on the same set of axes, which are shown here on the graph on the right, as shown here. Fx equals x squared is the curve here, and gx is 3 is the horizontal line here. Then graph the sum of these functions hx by just adding the y coordinates at each key points. Actually, we can plot some key points, and we can add the y coordinates along the axis to get the graph of the new function hx, right? This is the first method. Second, you can also use the second method, in which we can directly analyze the new function. New function is hx is x squared plus 3, right? So this is just the function of y equals x squared translated up by 3 units, right? So we can also directly draw the sketch of hx by analyzing the expression of hx. And therefore, note that this superposition can be thought of as a constant vertical translation of the parabola y equals x squared to produce the parabola y equals x squared plus 3. Understand? And from the graph or equation, it is clear that the domain of hx is x belongs to the real number set, and the range is y equals to the real number set, and y is greater than or equal to 3, right? The minimum point is 3. All right, then let's consider the second question. Second question, fx is x squared, gx is x, then hx is the sum of x and gx, which is x squared plus x, right? And again, there are two methods to plot the graph of hx. First, we can just list some key points here, and the new function can be obtained by adding the y coordinates along the x-axis. And the other method is to analyze the expression of the new function. We know that x squared plus x is a parabola, right? Which is x plus 1 times x. So this is a parabola that opens up and has two zeros. One of them is -1 and the other one is 0. So the line of symmetry is -1/2, right? So this is a sketch of the new function. And again, the domain is the whole real number set, right? X can be any real number. And for the range, apparently there is a minimum point, right? First of all, we can find the minimum point. Minimum point can be achieved when x is -1/2, which is 1/4 minus 1/2, which is -1/4, right? So the minimum point is -1/4. So that means the range is y belongs to the real number set, and y is greater than or equal to -1/4. This is a range, right? Okay. Please have a look at the solutions and let me know if you have any questions. All right, so let's have a look at another example question. The student council is telling teachers to raise money for new volleyball equipment. There is a fixed cost of $200 for producing the t-shirts, plus a variable cost of $5 for each t-shirt made. Council has decided to sell the t-shirts for $8 each. Question A, write an equation to represent the total cost C as a function of the number N of t-shirts produced. The revenue R as a function of the number N of t-shirts produced. Then graph these functions on the same set of axes, identify the point of intersection, and explain the meaning of its coordinates. Question B, profit P is the difference between revenue and expenses. Develop an algebraic and graphical model for the profit function. C, under what circumstance will student council lose money, make money? Identify, the last question is to identify the domain and range of cost, revenue, and profit functions in the context of this problem. Okay, again, I'll give you 10 minutes to think about this question by yourself, and after that, we'll have a look at the solution together. Okay, so let's have a look at the solutions of this question. First, the total cost of producing the t-shirts is just the sum of the fixed cost and the variable cost, right? Fixed cost is 200 and variable cost is 5N. So Cn is 200 plus 5N, right? And the revenue is $8 per t-shirt multiplied by the number of t-shirts sold. Therefore, Rn equals 8N, right? And if we plot these two, if we sketch these two functions on the same coordinates, we can see that first, Cn has a vertical asymptote of, Cn has a y-intercept of 200, right? So this is 200 here, and Rn has a y-intercept of 0, but Rn has a greater slope than Cn, so these two lines must have an intersection somewhere here, right? So in order to find the intersection point, we can combine these two functions together. So we can let Cn equals Rn, that is 200 plus 5N equals 8N, right? Therefore, 3N equals 200. That means N is 200 over 3. So this point here is 200 over 3, and the corresponding y coordinates is 1600 over 3. Understand? Therefore, the intersection point is 200 over 3 and 1600 over 3. Okay, next question. Profit is just the difference between the revenue and expenses. Therefore, Pn equals Rn subtracted by Cn, right? Which is 8N minus the sum of 200 and 5N. And after simplification, we can find that Pn is actually 3N minus 200. If you sketch this graph has a negative y-intercept. So it will start from here and all the way extends to the positive infinity, right? So this is Pn and this is n. When n is 0, this coordinate here is minus 200. And when n is 200 over 3, Pn is 0. So this equation represents the profit as a function of the number of t-shirts sold. And next question, student council will lose money if the profit is less than 0. This is modeled by the section of the graph of Pn that appears below the horizontal axis. Student council will make money when Pn is greater than 0, right? So this corresponds to the interval here, or if more than about 67 t-shirts are sold. Okay, and next question, we consider the domain and range for each of the functions listed here. Although each linear function extends to the left of the vertical axis, it has no meaning for n is less than 0, right? Because there is a meaning of the n. N stands for the number of t-shirts sold. So n must be greater than or equal to 0, right? So for each of the function here, the domain is n should be greater than or equal to 0. And when n is greater than or equal to 0, we can find the practical domain for each of the function. For Cn, the range is C is greater than or equal to 200. And for Rn, the range is R is greater than or equal to 0. And for the linear function Pn, when n is greater than or equal to 0, we can easily find that the practical range for Pn is actually P is more than or equal to minus 200, right? Note that n is restricted to integer values greater than or equal to 0. So we also need to put a restriction here. N belongs to an integer set. Of course, here C, R, and P also belongs to the integer set according to the expressions of this array values here, okay? When N is an integer, plus 200 is also integer. When N is an integer, 8N is also an integer. And for Pn, when N is an integer, 3N minus 200 is also an integer. So for all of the three functions, the range is within an integer set. Okay, so let's make a summary of what we have learned for today. First, you should be able to understand that some combined functions are formed by adding or subtracting two or more functions. Next, understand that the superposition principle states that the sum of the two functions can be found by adding the y coordinates at each point along the x-axis, and that the superposition principle also applies to the difference of two functions. Next, understand that the domain of the sum or difference of the function is a domain common to the component functions. Okay, so today we only discuss the sum and differences between functions. Tomorrow we'll be learning the product and quotient of different functions. All right, so the rest of the time you can use it to do today's homework, and do remember to complete it and submit it onto Google Classroom before the deadline, okay?
All right, class dismissed for today. I'll see you next lesson. Bye.